So now that our ball is moving around within the world, we want to be able to catch it and hit it by moving our paddles up and down. So we're going to do that right now. First thing we're going to do before that though is make sure that we save our scene. So if you see this little star symbol or the asterisk up in the top of the window up here and also in our hierarchy here, what that means is we've got unsaved changes in our game that we have made that haven't been saved yet. So if I just hit Control and S to save the level, you can see our star disappears and our scene is now saved. So with that saved, we'll go ahead and what we're going to do now is create a script to be able to move our paddles up and down. So what we're going to do for that script is go to Create C# script, and the script we're going to use will be paddle controller. Now before we go any further, it's important to note that you can't have any spaces within the name of your script. If you put a space in the middle of a script name, it'll give you an error that won't be good at all. So we need to make sure that we don't put any spaces within it in our game. So I'm just going to hit enter on that. And just an example of that, in our ball controller script, there's no spaces in the name itself, but much like we had when we created our variable in the last video, if we go to our ball now and scroll down here, you can see there's a space automatically being created by the name of our ball controller component down here. So we have our paddle controller script. We're obviously going to want to apply that to our paddles themselves. So I'm going to click and drag this paddle controller script onto our first paddle and drop it in there. And at the moment, we won't apply it to the prefab because we need to make some changes to it before we actually do anything. So now that we have our paddle controller script, let's open it up in Mono Develop. Give it a second to open here. There we go. Okay, so we've got our simple little script here, and basically all we need to do is make this move up and down on the screen. So if we wanted to move up and down, then what we needed to do is have a value that our paddles should move at. So the value we'll use will be the speed of the paddle. So we're going to create a public float for that. First of all, we're going to say public float speed. Very simple and very straightforward. And then all we're going to do is add the code to move our paddle up and down in the screen. So, as I said before, we have our start function, which is used at the very start of the game. But we also have our update function down here, which is used constantly as the game goes and is what we will use for taking input from the player. So as I said, if you're happening at 60 frames a second, you want to be checking and seeing is the player pressing any buttons at the moment. And we're going to keep it nice and simple and just make sure that we're checking for input from the player, and then if there is some input, we'll move our paddle. Okay, so how do we get input from the player? It's very simple, and it's a very handy element of Unity that's built in by default so that we can check it as we go. So to check for any input from the player, we have to use a thing called an if statement. So an if statement is basically just checking if something is happening, and if it is happening, it applies that or it applies a certain section of code. And the way an if statement is laid out is we have just the word if, then we have a bracket here, and then a close bracket, of course, and then within this bracket we check if something is happening. So what we'll be checking for is if the player is pressing a certain button to move the paddle up and down, and then if that is true, so if whatever little bit of statement that we have in here is true, then we have two curly brackets here like this, and then we say whatever is between these curly brackets, run that bit of code. So this in here we'll put the bit of code that will make the paddle move up and down. So just as a reminder to ourselves, we're going to type in here, we're going to type // and what // does is it makes it a comment. Whatever you write on the rest of this line won't be applied in code. So we're going to say here, okay, within here we'll have movement code. So that's just a simple reminder to ourselves. Obviously this is a very straightforward bit of code that we're doing here, but it's sometimes handy to use comments like this to make sure that you know what is going on in your script. So we want to check and see if the player is pressing a certain button. And what we're going to use for moving our paddle up and down is the letters W and S. We're going to use W for going up and S for going down. Now we could use the up arrows and the down arrows, but because we're making this, we want to make this simple tennis game a 2-player game, we're going to use simple controls on the keyboard. So we want both our players to be able to use a key button. So first of all, we're going to check and see is the player pressing the button to move up. And if they are, we're going to move the paddle up. So how do we check if the player is pressing the W key for moving up? Well, basically we say in our if statement here, we just say if input dot get key. So we're basically checking if a key is being pressed at the moment. So we're saying input dot get key, and the key we're checking for is key code dot W. And we put a little curly bracket there like that. And basically what that will do is say, okay, we're looking for input. We want to see if a key is being pressed and if that key is W. Now, one of the kind of simple things to remember when we're looking for a key is that there's 3 different phases of a key being pressed. Now, we only want to be checking if a key is currently being held down, and that's where we use get key. So we're checking to see if the W key is currently being held down at the moment. But there's 2 other options we can use for get key as well. We could also use get key down, and what that does is check and see if a key has just been pressed. So if the W key has just been pressed for the first time, then that's what get key down would do. So say, for example, that's helpful for if you have a game where a character is jumping. You want to check and see is get key down pressed, or if the character is shooting, you're checking to see at the very first moment the button is pressed, not just when the button is constantly being held down. There's also get key up, which naturally, if you think about it, is the opposite of when the button is pressed down. It's when the button is let go. So whenever you let go of a button, you are releasing it like that. So those are 2 other options to use for get key. They're handy things to remember, but we want to keep it nice and simple and just use get key. So we're just checking if W is currently being held down. We don't care when it was being pressed at all. So then within our little curly brackets here, we want to apply the code for moving our object. And the code we're going to use is very, very straightforward and very, very simple. So what we're going to do is access the position of the object and just move it up a tiny little bit. So if we go back into Unity and we go look at our paddle here, we know that within our view here, that if we move an object up and down like this, what we're affecting is the transform position of the object. So we know if we're moving this up and down, we're affecting the Y position of the transform over here on the right. You can see it moving and changing as we drag the object up and down. I'm going to set this back to be 0. So we know that that's how we move objects within the world. So within our script, we can actually access the transform position of our paddle. So if we go back in here, what we can say is very straightforward, just transform dot position like that. So what this will do is it'll say, okay, whatever object this script is attached to, get the transform position of that. So we know that our paddle controller script is obviously attached to our paddle, so we'll be affecting the position up here. So what we're saying is, okay, our current transform position, we want to set that to be equal to a new value, and the new value we are going to use for it is a new vector 3. So last time for our ball controller we used a vector 2 to apply the force because that was an X and a Y value, because we're using 2D, so we're only really worried about X and Y. But because it's Unity and it's built as everything is built, every object within the world is built with a 3D location, there's also the Z axis here. So we have X, Y, and Z. Now we're only going to be worried about X and Y. Our Z will always remain 0. We're not worried about that at all. But because our transform position has these 3 values, so we have to use a vector 3 to set it. We can't set this to be equal to a vector 2 because then it wouldn't know what to do with the z value and it would make an error. So in our vector 3 here, because we only want to move it up and down, we don't care, we don't want to make any changes to its position on the x-axis. So the value we want to have for the x here, we want to make sure that that doesn't change. So we'll take whatever is the current transform dot position dot x. So our current x position, which will be -8 for this paddle, and we want to make sure that that just stays the same the whole time. So we're not making any changes to that. We're just reading it from what it currently is and setting it back to be the x position of our transform here. So then we hit a comma there. So now we're making a change to the y position, and we know that we definitely want to make a change to our y position. But what we want to do is take what our current position is, so that'll be transform dot position dot y, and because we're moving up, we want to add on a certain value. We want to basically add on the speed here. But there's a slight issue with just adding on the speed. So I'm going to say here transform dot position dot y plus speed. Very simple and very straightforward. But the problem is, if we just add the speed, that can make a huge difference depending on how fast the player's computer is. So say some computers could be running at 30 frames a second and some computers could be running at 60 frames a second. What would happen if we just add on the speed? So say our speed was 0.1, for example. If our speed is 0.1 and we run at 30 frames a second, then that means it will move up by 3 in 1 second. But if we were running at 60 frames a second, it'll move up by 6 in 1 second. Which means that if a player has a better computer, then the game will be suddenly faster and probably a lot harder to play at the exact same time. So what we want is to make sure that our players have the same experience no matter how fast their computer is. Now, to be honest, this is a very simple little game, so if you it wouldn't be all that surprising to be getting a few hundred frames a second, which would make our paddles completely uncontrollable and of no use to us at all. So what we need to do is adjust this speed value. So I'm going to put a bracket before our speed here, and we're going to multiply it. So multiply, which is our little asterisk symbol, speed multiplied by a thing called time dot delta time. I'm going to close that little bracket there. And time dot delta time is basically how long it takes for an update loop to happen. So as I said, our updates are constantly happening over and over and over again. And basically time dot delta time says how long has it been since the last update. Now that'll be a tiny fraction of a second. That'll be like 0.02 of a second or something like that. But basically what we're then doing is multiplying that by the speed. So it's adjusting the speed down and compensating for it by the frame rate. So now if we have a game running at say 30 frames a second, then our speed here will be divided by 30. But if we have it running at 60 frames a second, our speed will be divided by 60. So now our speed will actually be a figure of 1/60th, but it'll be happening 60 times a second. So basically what will end up happening is overall our speed will always be, say if we set our speed to be 5, our speed will always be taking 1 second to apply 5 spaces of movement, no matter what. And it's a very handy thing to be using within Unity. And that's basically all we want to do on the y-axis. So now if we hit our our comma there, and then we need to apply the final value on our z-axis. So again, we don't want to change what's currently there, so we'll just use transform dot position dot z. Okay, so let's save this and go back in. Of course, at the moment we can only move up as we're going, but we want to make sure that we can test it out as we do things here. So here we go, we've got our speed. I'm going to set that to be 5 just for the moment, and I'm going to hit play here, and we should now, if we tap W, we can see our paddle is moving up just like that. Of course, it's gone too high now, I can't move it back down. So let's apply some code to move it back down the screen. And you can see our speed wasn't being applied every frame of a second. We weren't crazily jumping up madly, but that is our speed that we'll actually be able to control and be able to deal with nice and simply. So let's go back into our paddle controller script. So we have it checking for if our player is pressing W down and we're moving them up, but then we want to make sure that we can move back down the screen. So we'll say just below that, we'll have if. We're going to use the exact same bit of code here. We're going to copy all of this here, our input.getKey. We're going to copy that, and instead of now using the W key, we're going to use the S key, because that's what's going to be our down movement. Then we have our curly brackets again. We're going to copy the movement code that we applied here. So we're going to copy all of this here, like that. And we're going to paste it inside here. And now instead of adding on the speed multiplied by time.delta time, we're going to take away the speed, like that. So we're going to save this and go back in here. Wait for it to compile. And now if we hit play, we can move up and we can move down. So now our paddles are able to move. They're moving a little bit slowly. Actually, I might set the speed of this to be 10. Yeah, that feels a bit better. So our paddles can now move up and down to their heart's content. So let's apply that to the other paddle now. Here we go. We'll stop the game. As I said before, when you make a change when the game is running, it doesn't apply to the game outside of it. So we can see we changed our speed to be 10, but it's gone back to be 5. So let's actually set that to be 10 by default. Then we're going to apply all these changes to our prefab. So we're going to hit apply like that. And now on our other paddle, I'm actually going to move this down in our hierarchy below our first paddle, just to keep them together nice and simply. But we can see we've got our script now applied to the other paddle. So if we hit play, both of our paddles now will move up and down together. You can see our ball is now bouncing against the walls. It's spinning around like crazy, which is something we don't really want to happen. We'll fix that now in a second. But you can see we can actually play our game and actually get some fun going on. So obviously we don't really want both of our players controlling the exact same. We will make some changes to that a little bit later, but for the moment we need to get the basics of the game all working properly. Before we go any further, I'll just make a simple change to our ball to stop it rotating like crazy. If we go to our rigid body and if we go to constraints here, we can freeze the rotation, so that means that our ball won't ever spin around when it's hitting against the wall, or hitting against the walls or the paddles, which we don't want it to do at all. So now it'll just stay in the exact same position the whole time. Okay, so we've got our paddles moving up and down, but of course at the moment our ball just constantly bounces between them. It's not very hard. So let's make some changes to how our ball is bouncing when it hits the paddles. konnichiwa